Okay, 17 says find the center, vertices, foci, asymptotes of the hyperbola sketch its graphs. So what did we have to do in this one before we can do any of that stuff? Complete the square, right? So we start out by getting our x terms together and our y terms together. And I miswrote that. That was supposed to have been 54, right? 54y back to blue. Minus 50 back to blue. 54y. And I'll move the 80 to the other side. Okay, then because of that negative 9 is not a 1, I need to factor it out. X squared plus 2x. Okay. Minus 9 times y squared plus 6y. Okay, what do I add to this position to complete the square? 1. 1. Okay, what do I add to this position to complete the square? Plus 9, right? What do I add to the other side? Negative 81, right? This negative 9 times 9 means the effect of putting a plus 9 in that position was to subtract 81. So we subtract 81 over here. Okay, so we have x plus 1 squared minus 9 times y plus 3 squared equals 0. All right. Now, normally at this point, we're trying to make the right-hand side look like 1 by dividing by the right-hand side, but we can't do that. Okay? If you remember on day 1, when we looked at the different conic sections, underneath it gave us, this is what happens if you push the plane in these particular places, like if you go to the middle between the two cones. Those are called degenerative cases. You don't get conic sections. And in one of them, you get 2 straight lines instead. And the way this turns into 2 straight lines is, add this to the other side. And then take the square root of both sides. Right? Then you would get x plus 1 equals 3 times y plus 3. And because we took square root, we know there's plus and minuses involved. It doesn't matter which side you put it on, but I'll put it over here, plus and minus. So that's 2 straight lines. One of them is what you get if you solve this for y with the plus, and one of them is what you get if you solve for y with the minus. In the end, it looks like 2 straight lines. Again, if you go back to open pre-cal, that was in 10.1 slides. Those are good enough. That's this one right here. Right? It's a degenerative case because it goes right through the vertex. If you go through the vertex, you're not going to end up getting the conic section of like one of those. So that's why 17 works out like